Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about a Leetcode question number 594, longest harmonious subsequence. Okay, we define a harmonious array as an array where the difference between its maximum value and its minimum value is exactly 1. Okay, it is equal to 1, not it is less than or greater than. Okay, it's equal to 1 like that. Okay, given an integer array nums, return the length of its longest harmonious subsequence among all its possible subsequence. Okay, fine. So just see this example. This is the array they have given. What is the longest possible harmonious subsequence we can get? I can say this is the longest harmonious subsequence I can get. Okay, what is my subsequence first of all? If I give array like this, okay, then subsequence is said to be a subset of this array which are in order. It not to be a contiguous in manner. Okay, so from this I can say 1, 2, 2 is a subsequence. 1, 2, 3 is a subsequence. 1, 5, 7 is a subsequence. I cannot say 7, 3, 5 like this. I cannot take in this order. I can take only in order. Okay. Okay, fine. Then also all subset is also a subsequence. Okay, and this whole array is also a subsequence. Fine. Now hope you understand what is means subsequence means, right? Okay. From this I can say this is a subsequence. This is a subsequence where there is a minimum difference between the maximum and minimum element, right? So it is 3 and 2. Sorry. In this subsequence only, the maximum and the minimum values absolute difference is equal to 1, right? 3 and 2 is equal to 1. Simple, right? Okay, fine. Now, see this second example. It is 1, 2, 3, 4. Here I can take 1, 2, or 2, 3, or 3, 4. Okay, among this, there are this much elements. From this, I can say length of 2 is a subsequence length, right? It's a maximum among all. Okay, fine. Now, see this. There are 4 ones. We cannot form 1 minus 1 is equal to 0, right? So we cannot form absolute difference between maximum minimum element and it is exactly equal to 1. So here I will return what? 0. Hope you understand. Okay. So what is the brute force approach? Very brute force approach is generate all possible subsequence and check whether the maximum and the minimum numbers differences equal to 1. If it is not so, just don't take it. If it is so, then take that length and take the maximum among all the length. Okay, so this will be exponential. It will be something like 2 power n into n, like that. Okay, the time complexity will be approximately this much, and my space complexity is also approximately 2 power n or n. Okay, so this is the basic brute force approach. Can we still optimize it? Okay. Let us understand what are the things that are asked in the question. Okay, so in question they only asked what is the length. They didn't ask what are all the elements. So this is the first clue we got. Okay, fine. Now the second thing we want to get into mind is when my absolute difference or difference will be minimized. When my difference will be minimized in an array, how to find the elements in the array which are in a minimum difference? So at that time my mind goes to what? Just sort it. I will tell you why we are doing a sorting operation here. Just see here, 1, 2, 2, 2, 3, 3, 5, 7. So this is the element, right? Now see here, I can say these all are the elements that have what? Have absolute difference of 1. Can you understand this? I just sorted each and every element so that I can have a minimum absolute difference in next to next. Yes, just tell me 1 and 2 are closer or 1 and 7 are closer. 1 and 2 only closer. We want to take the closer number such that their absolute difference will be what? Minimum. We want only 1, right? So it will be minimum. So I can take this, or I can take these elements. Yes, other than that we cannot take anything, right? Because 3 and 5 is absolute difference will be 2, and 3 and 7 will be 4, and 5 and 7 will be also 2. So I have only 2 possibilities. One possibility is I can take this, And another possibility is I can take this. Among this, I will take this white line subsequence. Okay, so it will be length of 5. Hope you understand this, right? So what is the algorithm used here? First of all, sort them and just take here and move up to which this condition satisfied. Okay, then move here, go up to which this condition is satisfied. Then again move here, go up to which this condition is satisfied. Like that, we are going here, going here, going here, going here, going here, at last, up to last. And we are just taking what is the maximum possibility we can get, what is the maximum length we can get. Okay, so this leads to a time complexity of O of n square, because we are traversing to each and every elements of the array, and also again we are just traversing, right? So, and space complexity will be what? O of n, because we are sorting, right? In sorting we can use a merge sort, or if we use a selection sort, it will be 1, O of 1 approximately. So time and space complexity analysis would be like this. Okay, whether we can still optimize this time complexity. Okay, let us think about it. Fine. So let me draw a hash map, and I am going to count each and every element's occurrence or frequency. Okay, first of all, 1. So 1 occurred how many times? Is the first time, right? So 1. Now then 2. So 2 one time, then again 2, so 2, then again 2, it is 3. Next 3. So I will add 3 one time, then again 3, so it updates, and 5, so 5 1, then 7 7 1. Fine. Now what is my next step is I am going to traverse among the array. I am going to traverse among the array, and I am going to check whether it's +1 and -1 exist or not. Fine. So we can also iterate over this hash map also, because this array elements, all unique values will be present here only, right? So I'm going to iterate over this hash map itself. Okay, fine. Let us iterate over hash map itself. First of all, it is 1, right? So whether we have 1 plus 2, sorry, 1 plus 1 is equal to 2. Yes, we have 2. Okay. So if I take 1 and 2 alone, what is the count? So 1 occurs 1 time and 2 occurs 3 times, so it will be 4. Okay. If there any 0? No, there is no 0, because 1 can have what? Can have a plus or -1 difference, right? So which is equal to 2, otherwise 0. These are 2 possibility I can have. Can you understand this? I'm just putting each and everything into an hash map, okay, and taking the count of each and every values, so that I'm going to take the condition in the reverse way. Like they are asking us to find what are the minimum and maximum values different. Absolute difference should be what? Should be equal to 1. Just I am putting like I have one value. Let us be it is minimum. Minimum is equal to what? 1 plus maximum, right? And maximum is equal to what? 1 minus minimum, or minimum minus 1. It goes there. Yes, minimum minus 1. Can I understand this? So I'm going to do what? I'm going to do a number with plus or minus 1. First I do a plus operation and take a result. Then I'm going to do a minus operation and take the result. Like that. See here. First of all, I'm taking this 1, and what are the one's neighbor I can take? 1 plus 1 or 1 minus 1. So there exists only 2. So I am taking that 1 plus 1 alone. So 1's count will be 1 and 2's count will be 3 and the total will be 4. Okay, fine. As of now, 4 is the highest subsequence length we got, right? Why I am taking like this? Because subsequence is not a contiguous manner. We can take any order, right? We can take any numbers, non-contiguous number, but in order only. That's why I'm doing like this. Okay. Now I am just going to this 2. Okay. So 2 plus or minus 1. So I can take either 3 or 1. Okay. If I take 2 and 3, what are the counts? So 3 plus 2. If I take 2 and 1, what is the count? It is 3 plus 1. So here comes 5, here comes 4. So 5 is the maximum among now. 5 is the maximum among now. So my result will be greater to 5. Okay, now then I am going to this 3. Okay, whether 3 plus 1 is there, this is equal to 4? No. 3 minus 1 is there? Yes, 2 occurs. So what is the 2's count? It is 3. And what is 3's count? It is 2, right? So it is equal to 5. So 5 is already updated here. So we don't want to take consideration because it is not maximum, right? Already 5 exists. Okay, now I am going to this 5. Whether 4 exists? No. Whether 6 exists? No. Now I am going to this 7. Whether 6 exists? No. Whether 8 exists? No. So don't take it. So my maximum value occurred is what? 5. Can you understand this? So the maximum length of a subsequence is 5. Okay, so this is how you want to keep track on these problems, right? Just solving many problems, you can find different solutions. So this is one of the solution I found. Okay, now I'm going to tell you how to do this in the sliding window technique. Before that, we can see what is the time complexity. So time complexity will be O of n log n, where n is for traversal and log n for just putting into this hash map and taking from this hash map. And what is space complexity? It is O of n because we are using what? Hash map. Okay, now let us see an alternate approach, which is a sliding window approach, because you want to know about more and more approach, so that while solving next problems, you can go with your own approaches. Okay, I learned like that one. Okay, now what is the sliding window approach? Let us rewrite that in a sorted order. So let me write here 1 2 2 2 3 3 5 7. Fine. What is the sliding window method? Usually I will take a L pointer here and R pointer here. So right and left pointer. Now I'm going to iterate over each and everything, and I'm going to check whether the difference is exactly equal to 1. Okay, first of all, what is the L pointer and R pointer pointing? It is 1. So 1 minus 1 is equal to 0. So 0 is not equal to 1. They are asking 1 only, right? So not equal to 1. So don't take this as a consideration. Okay, now let's go here. Okay, now 1 and 2. Okay, 1 and 2 is what? So 2 minus 1 is equal to 1. 1 is equal to 1, right? So we want to take it. So just take it. How many elements? 2 elements. How to take it? R minus L plus 1. Sliding window size formula. I already stated this in the sliding window introduction video itself, right? Go and watch it. So I will give the link in the description. Fine. Now my window size will be what? 2. So 2 will be updated in the result. Result is initially as 0. Now it is 2. Now again go further. Now also the observed difference satisfy the condition. So make this as 3. Sliding window size. Now make this as 4. Now comes the twist. Now see here, 3 minus 1 is what? 2. 2 is greater than 1, right? Greater than 1. So at that point, what should I do? Shrink it. So while I'm shrinking it, it comes here. Okay, now again check whether 3 minus 2 is equal to 1 or greater than 1. It is equal to 1. So don't worry. Keep it. Now what is the sliding window size? It is 4. So already it's 4. Don't want to update it. Okay, fine. Now increase. Now again it satisfies the condition. Now the sliding window size is 5. Update as 5. Now go here. Now see that 5 minus 2 is 3. 3 is greater than 1. Shrink it. So shrink. Now satisfy the condition. No. Shrink. Now satisfy the condition. No. Shrink. No. Shrink. No. Shrink. Now it satisfies the condition of it is not greater than 1, but it doesn't give a difference of equal to 1. So go along. Now 7 minus 5 is equal to what? Is equal to 2. 2 is greater than 1, right? So shrink it. Now 7 minus 7 is equal to 0. But it is not equal to 1. So it doesn't satisfy the condition. So move forward. That's it. Ends come. Okay, fine. Now what is the result? It is 5. Can you understand this sliding window method, right? So what is the time complexity? I can say n log n because we are doing a sorting operation, right? And also traversal operation. So it will be plus n. Approximately it is equal to what? O of n log n. And what is my space complexity? I am using a merge sort. In Python, I am using a sort of function which uses the merge sort and dim sort, which also takes a space complexity. So this is the time and space complexity of this solution. So these are the 3 types of solutions. And addition to this, there's a brute force. So 3 plus 1, 4 solution. Fine. Let us see the code. See here. First we can see that slightly optimized brute force code. we want to sort it. Okay, so this is basic greedy approach. Okay, now I'm going to iterate over every elements, and I'm going to iterate from the current element till the last element. Now I'm going to check whether the absolute difference is equal to 1. If it is so, I want to take that into my consideration. If it is not, if it is greater than 1, then I want to break it. Can you understand this? So this is the basic brute force approach. Sorry, basic brute force approach optimized version. Yes, it is submitted successfully. Now let us see the second approach. So second approach is something like a hash map approach, where I am just taking every count of each and every elements, and I am setting m as 0. Now it keeps track on the result. Now for I in d dot keys, okay, I am traversing in the hash map, and if I plus 1 is in d, which means if the current element plus 1 exists in the hash map, then I want to take the current element current element count and the plus 1 count, and see whether it is its sum is greater than the maximum, and update it, right? You want to take the max. Same thing applied to the I minus 1 also, if it is present in that hash map only. Okay, now return m. That's it. Let me submit it. Yes, submitted successfully. Now let us go to the last approach. Last approach is sliding the approach. First I want to sort it, then result is equal to L is equal to 0. Now I am iterating through the array. Now I am checking whether that my R pointer's value minus my L pointer's value is greater than 1. If it is so, I want to shrink it up to this condition dissatisfied, right? This condition becomes false. Okay, now if that value difference is equal to 1, then only I want to do what? I want to take that window size and take the maximum among the result and the window size and return the result at last. Okay, let me submit it. Yes, it is submitted successfully. Thank you.